Hello everyone. Today I'm going to start working on a new sensor that is SHT25. To gain more knowledge about this sensor, what we have to do is to have a look over the website that is controleverything.com, and here we have to log in and search for the sensor that is SHT25. Now let's have a look over and better perspective about the sensor which we have, that it's a humidity and temperature sensor, and as you can see these are some of its features, and this is the sensor. Now you can also purchase the sensor from this very site. For this video session, what I gonna do is to have the interfacing of this sensor SHT25 along with a particle photon, and for that we require a code. So have a look over the resource tab, and here comes the particle code sample. Now you can also have the code sample as a zip file from here. You can download it from here. Also you can have the code from github.com, and the repository there is control everything community, which you are able to see on my screen. Now what we want is to have setup connections, hardware connections, so that we can have the interfacing of this particular sensor. In the hardware section, first of all our requirement is the humidity and temperature sensor SHT25. Next we require a particle photon, which you can see on my screen, and this here is an I2C Shield. It's available on the website controleverything.com, and the requirement is very essential in making connections with other I2C devices, and the connection should be a lot easier, so we use it. Now gently press over the particle photon over the I2C Shield and make a connection. Now this here is a connecting cable. This is very useful in making the connection among the sensor and the particle photon with the shield, and we have to apply a rule that while making this connection we have to be sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly to the I2C Shield. The last part is to power up the particle photon, and we need a micro USB cable just like this, and gently put it over the power jack. So we are done with the connections part. Now what we require is to have a look over a particle code, so that we can have a better perspective regarding the code and the interception. Have a look over that. Well, for the interfacing of the sensor SHT25 with the particle photon, we require a particle code. To get the particle code, what we have to do is to log in to github.com, and here we have to search for the repository that is Control Everything Community. Here we go, and here we have to search for the sensor SHT25, and this is the required sensor, and this is the particle code. Let's have a look over the instructions we need to follow to pursue. As you know, we have to log into our particle photon and set up our device on the steps that are being provided on this very link. Please have a closure link on this. Let's have a look so that you can have a better perspective regarding that. As you can see, these are the guidelines we have to follow to start and connect particle photon. Here, as you can see, using OS X, installing node.js commands are there, Windows and lot operating system. Similarly, going for the second part, which is to download and git pull the code, and on the online ID we have to copy the code, and build.particle is the online ID where we have to paste the code, create a new file, and then we can save there. And last part, we have to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs at dashboard. And this is the link for the dashboard.particle user logs, where you can have the relevant results regarding the code working. So these are the instructions you need to follow to pursue the code, and let's have a look over the code. As you can see, it's a .in extension file. As you can see, first of all in the code we have included application.h and spark winding I2C.h header files, and we have defined the address of the sensor, that is 0x40. We have float, humidity and ctemp, ftemp as the variables, and here in the void setup we have some variables as you can see. Now we have initialized I2C communication as master along with serial communication with the baud rate equal to 9600. In the void loop function we have to send some commands to start the sensor. As you can see, we have sent humidity measurement command no hold master, and the command is 0x f5. And then we have requested and read 2 bytes of humidity data, and along with we have the conversion of the data which is according to the datasheet of SHT25. And then we have the output display on the dashboard. As you can see, relative humidity percentage RH is the unit. Similarly, following this pursuit, we have to send temperature measurement command no hold master mode and it's 0xF3. Similarly, we are reading and requesting 2 bytes of temperature data. Then the conversion part of the temperature data comes into place. At the very end of our code, we have the output data on the dashboard. As you can see, temperature in Celsius and Fahrenheit scales. So this is how the code works. Now what we have to see the practicality of this code along with the sensor and the particle photon. Now let's have a look over that also. Well, let's have a look over the working environment, and for that first step is to copy this entire code of the particle, and now here open up the build terminal as we have discussed earlier. In this build terminal, in the link, what we have to do is to paste this entire code. Now paste the entire code here, and here save it SHT25 and then save it, then verify and compile the code. As you can see on my screen, it's done. Now flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is good to go and we can have our output data to be displayed on the screen. So just now we have our magenta flash which confirms it's good to go. To have the output on the dashboard, we have the dashboard and the user logs is there. As you can see, the result will be displayed. And as you can see, we have the relative humidity along with the temperature in Fahrenheit and Celsius. Now, when I place my finger over the sensor, you can see the change in humidity and temperature. Now, when I again do that, the changes are there for humidity and temperature. So this is how the sensor responds to the particle load along with the particle photon. Now what we require is to have a look over the application's benefits and the features of the particular sensor SHT25. Let's have it. So we have seen the sensor SHT25 humidity and temperature sensor with a completely new designed CMOSens chip, a reworked capacitive type humidity sensor and an improved band gap temperature sensor. The performance has been lifted beyond the outstanding level of the previous sensor generation. For example, measures have been taken to stabilize the behavior at high humidity levels. It is applicable in a lot of markets like industrial, HVAC, IoT, home appliances and automotive grade. The humidity and temperature sensor SHT25 can be purchased from the website controleverything.com, and you can have the code from resource tab. You can download the code as a zip file from there. Also, you can have the code from github.com, and the repository there is Control Everything Community. In the end, I just want to make it clear that in case of any part where you have some queries, you can reach us on controleverything.com and you can post your comments on the community page of this website like this. For blogs and articles, you can have a look over instructables.com and you can watch us there. Also, to subscribe more video tutorials like this, you can go to our YouTube channel. In the end, thanks for watching and have a great day. Thanks a lot.